Welcome back to episode 78 of the Block Runner Podcast. I'm your host, William, always here with your co-host, Iman.
What's going on, fellas?
And today we're bringing Arthur Gervais, CEO of Liquidity Network. Welcome, man.
Thank you very much, William, Iman.
Thank you. So we have a couple of questions, but before we start, I'm curious, where are you located?
We are located mostly in, Switzerland, but as it's a decentralized project, we have people around the world basically working on different aspects.
Yeah, the reason why I ask is because I think everybody is experiencing the pandemic a little bit differently. Over here, it's actually gotten worse in Texas, in the States. So how are you guys faring right now with the pandemic?
It's fairly okay, I have to say. Obviously, we had, I think we had like one potential corona case in the team, which was quite, quite a shock, but nothing too serious. Everything is fine.
Okay, good.
Yeah, that's the benefit, I guess, of the industry we're in, right? We're all on the computer.
Yeah.
We don't necessarily all have to be in offices to collaborate, but that's interesting. You said you're like, yeah, it's a decentralized project. Obviously, everything in the crypto space is aiming towards that goal. So, like, is that difficult? Like running a project where like not everybody is in the same location. You know, are there any kind of?
Yes, it certainly comes with its challenges, I find. It's certainly very different from running from basically a normal company where you have an office and people are in the office, right? So if you have a decentralized project, then I mean, people can show up, they cannot show up, they can do things, they cannot do things. But ultimately, in a decentralized project, it's really important to foster decentralization. There should not be like a single actor that can control everything, that can decide on everything, because otherwise, this is not in the spirit of blockchains, right? So for example, we just recently open sourced all our software stack. So now you can run a hub. You can have the mobile wallet, which works both on Android and on iOS. You have the client in JavaScript. You have the Explorer and other tools. It's everything open source now. And we're quite excited to onboard basically new members of the community that will operate hubs. So we just had a deadline on the 1st of August for applications for a hub operator program where people can operate a liquidity network hub. And they get subsidized to do so. So they can build their own user base, their own ecosystem, their own off-chain ecosystem to perform payments, but also to swap assets if they want to enable that.
Oh, swap assets within the Ethereum ecosystem?
Within the off-chain hub. So we've kind of built a payment hub. Which allows you to, so if we would join this hub, then we can perform payments among each other, right? If I deposit one Ether into the hub, then I get one F Ether, which I can send either to you or split it in whatever denomination I would like to.
Sure.
But the software and the design of the protocol also allows you to do swaps. So here it depends a bit on your regulatory aspects and of where the hub operator is running, but you can technically it certainly works.
No, that makes sense. So once we create a hub, then we can do swaps. But which currencies are you swapping? Is it cryptocurrencies or is it fiat currencies?
So if you want to operate a hub, you basically need to take the software we have. I mean, obviously you check it, you look at it, what it is, because you shouldn't run any code without actually looking at it.
For sure. Yeah.
Then you deploy it. So deployment of a hub costs a bit more than $100 at the current gas prices. I think it was about $70 at 35 Gwei. And I think current costs are like 50 or so. So it's a bit higher. Then you have a hub running. So what the hub does, he can onboard user. So you can join a hub by sending a signed message to the hub. There's no on-chain transaction. That's the cool part. So in this off-chain technology, you join this hub without any on-chain transaction, and you basically have a ready account in this in this liquidity network commit chain. We call it. It's like a hub. It's a commit chain. It's the same thing. Now, if you do a transaction, so if you want to perform a transaction, you first need to get some funds. Either you get these funds from another account that sends them to you off chain on this off chain system, or you deposit. For example, you can deposit 1 ETH into the contract or smaller denominations. And this will convert the 1 ETH into an F ETH token.
Okay.
And this F ETH token is what you can transmit then off chain.
Oh, interesting. So to put it into context, so we have our own DApp application, and it's sort of like an app store for Decentraland. I don't know if you heard the project called Decentraland. It's a metaverse.
Yeah.
And so what this DApp does, it helps distribute content, user created content to the world in a few clicks. And so we have our own community. And so what you're saying, we can use the Liquidity network to create a hub amongst our own community, and people can transact with our DApp and others within that community within this hub. And you could. So what are the limitations in the currency for the hub? Is it any cryptocurrency, or is there a specific defined set of currencies?
So if I'm not mistaken, Decentraland uses NFTs, right? So you have ERC721s. So we only support fungible tokens. So ERC20 or 777, for instance. We have basically any ERC20 is a no-brainer to integrate. It's very simple.
Interesting. So
is it possible to like integrate NFTs down the line, or maybe like replicate this model of decentralization and scalability for like an NFT trading platform?
So the way we map a user account balance is by, we basically have a Merkle tree of like an indexed Merkle tree. So the root, we have the root, and then the bottom are the account balances of the users, right? So I'm not exactly sure how we could map an account balance, which is an interval between, like, for example, I don't know, whatever, 0 to 20 coins. How we could map this to a fixed, like to an NFT that you submit into the. I don't think the design is particularly suited to that, but there might be ways.
Yeah, definitely it's something to explore. I think we're kind of dabbling, like in our past podcast, we've been discussing, because not only do we have this platform, this distribution platform, we're actively creating game experiences, blockchain games in the Decentraland world. And that comes with experimenting with ERC1155 protocol, in-game NFTs, stuff like that. And basically all the same issues that any crypto project, the blockchain gaming space is facing the same thing, meaning like the gas fees are just way too high to where it's like not viable to create or to expect any type of engagement from a player base, because it's just, there has to be a way around, or like some kind of solution to this problem. And we're always trying to think about what that is for our case, the NFT ecosystem.
So have you looked into like other, I don't think any payment channel does support NFTs as far as I know, or state channels. Do they support NFTs? I haven't looked into it. Or did any of the Plasma versions allow for NFT transfers? I'm also not aware. Have you looked into this?
I don't think it does, but within the smart contract, you can, I believe, use the Plasma network to exchange ERC20 for an NFT. So I believe that's how you would do it.
Right. You can always, what you could always do is you can map an NFT to an ERC20, right? And then just trade its parts. This you could do, right? So that's actually maybe a funny idea. But if you have an NFT, you could add a coin to a no-cost hub as this NFT. That's the coin that you add.
That's a good idea. That's a good idea.
And then you just slice it, and it's fungible. Like the parts of it are fungible.
So yeah, that's actually a good idea. So there's a similar project to this, but the idea would be that you take an NFT and then you map it to, let's say, 100 ERC20 tokens, and then then you can split it within the hub, and then and the collective represents the entire value of the NFT potentially, or maybe the it's sort of like an equity of the NFT. right?
It is.
You own a
Yeah.
percentage
Yeah.
of the NFT.
Yeah.
That's interesting.
Yeah.
So let's take it back just a little bit. So let's get some perspective on, because Liquidity Network is sort of an off-chain scaling solution. So let's talk about what the solution is for in terms of the application towards Ethereum. So do you, in your own words, like how would you describe Ethereum's scalability problem?
The problem is basically something that, how to say, there is a limited amount of space or limited amount of data that we can exchange among all validating peers in a peer-to-peer network. Right?
Mm-hmm.
So I think that's basically the gist of it.
Yes. Yeah. So it's like it boils down to Ethereum being able to process, let's say, tens of transactions per second. Mm-hmm. Is that because the block size isn't big enough to hold more data, or I mean, what's the root issue with the scaling in Ethereum?
So I mean, this applies basically to any blockchain that is based on some kind of proof of work scheme. So you have a consensus mechanism, right, where you elect a leader who decides what's the current truth. Right? You want somebody to say this transaction happened, and he will also say this one did not happen. Mm-hmm. I mean, he doesn't say it, but if he doesn't mention a transaction, then the transaction that wasn't mentioned didn't happen.
Sure.
Right? So it's really about what is the representation of truth, and somebody needs to decide on the truth. Even though we are a decentralized network, somebody in the end has to decide. Now, the idea of decentralization is to allow like a diverse set of entities geographically distributed to have a chance to have a say at some given point in time, right? Mm-hmm. Now, in Bitcoin or Ethereum, in Bitcoin it's the block size, in Ethereum it's the gas limit, right? Because a transaction can be very small, but can take up a lot of computation due to loops. Now, this complexity, whether it's now the size or the gas costs that are measured, it's basically the same concept. It is like the more complex or the more complex this computation becomes, the less everybody can do this, the less likely everyone in the network can do it, right? It's like, it's literally like you have a distributed computer, right? You want to, I don't know, you want to draw a line on a picture, right? If you have like Photoshop, this like in a decentralized Photoshop that is running on your computer, on my computer, and on 10 other computers worldwide distributed, and I want to draw a line on this picture in this decentralized Photoshop, then all these nodes, they will have to do the same computation, right? And because they're physically distributed, there's a latency, there's a communication latency. I mean, in this call here, we probably have a communication latency of, I don't know, maybe 40, 50 milliseconds, depending on your internet connection. But this is just because we're directly connected to each other. Now, if I'm connected to somebody else behind me, and there's again somebody connected behind him, then this latency kind of accumulates, right? So there's an inherent, I mean, the academics say it's an asynchronous network. So asynchronous in the sense that you transmit data and it only trickles down the network given a certain time. So Christian Decker made actually the first paper on measuring the information propagation speed in Bitcoin. And he had a very nice plot in his paper where he shows that there's quite a long tail. So like to get to 100% of the nodes to receive all the data takes really a long time, like much longer than like a few seconds.
Sure.
While like 80, 70% of the nodes receive data really fast. So in the end, like let's say we all go to sleep. We sleep for 10 years and the internet got better by then, because some people didn't sleep. Then Ethereum would be just more scalable instantly, right?
Interesting.
We can like if the propagation speeds of the network become better, the throughput gets better by default, because the inherent tension in scaling is the network propagation and the block time interval. So if you have, or like the block size and the block time interval are two parameters that you have to look at in proof of work blockchains, and you have the network layer speed. So the bigger the blocks, the slower they propagate, and the more likely two miners find the block at the same height. And if two miners find the block at the same height, we have a fork. And if we have a fork, then an adversary who wants to attack the network, either through double spending or selfish mining, will have an easier game at attacking the network. That's because, I mean, in Germany we have the saying: if two people fight, like there's a third one who will enjoy, who will reap a benefit from it, right?
Right.
And it's literally that, right? If you have two miners that are not working together but both like creating a fork, then an adversary has an easier game because now the processing power of this network is kind of smaller. Because like if the honest network is really like 50-50 on the fork, then the adversary basically only needs less power to attack this network, right? It's very intuitive kind of, because these two people, they don't agree, or these two networks, they don't agree because they're working on two competing chains, but only the longest can win in the end.
Sure. That makes sense, because if you try to scale Bitcoin by just increasing the block size from 1 megabyte to 10 gigs, then you would have to send 10 gigs every 10 minutes to all miners, and then at that point, it would be the miner who mines it first, and then you would have a more likely situation where there's a fork, just because miners have different sets of data in those 10 gigs, right? And so
correct. Yes. So I mean, that would work if the internet becomes faster, but
right,
it's not fast enough. Yeah. So actually, I mean, this was my last paper in my PhD dissertation that was quantifying what parameters can you use and what kind of scalability do you get, and what security trade-off do you compromise if you scale up the block sizes or lower the block interval. So I built a Bitcoin simulator that's also open source, where you can parameterize Bitcoin with any block size or block time interval that you want to. Let the thing run, and then you get out a stable block rate. The stable block rate quantifies how many stable blocks you have because you have forks in the chain. And Ethereum, for instance, has, just by definition of its smaller block interval, it has a higher stable block rate than Bitcoin. But this doesn't necessarily mean that it's less secure, because in Ethereum you would not wait 6 block confirmations as you would in Bitcoin. So in a sense, 1 block confirmation in Bitcoin is not equivalent in terms of security to 1 block confirmation in Ethereum.
Interesting.
I just have throw a random question out there. This isn't necessarily too related to the liquidity number, but I just kind of wanted to see your opinion on these on-chain scaling proposals that have been out there in the space now, I guess, for the last few years, comparing, proof of work versus proof of stake, and like these whole blockchain 3.0 versions that have been out there, like EOS, Cardano, the whole delegated proof of stake. Do those make sense to you? Are they flawed in any way as far as like security risks go? Or is like Ethereum the network that we should all be working to improve, and projects like yourself gearing to fix these scaling solutions? What do you think?
It's a very broad question, right? But,
yeah, it is.
So I don't think one rules them all, right? I think there's a whole garden of opportunities of different technologies, and this diversification is what brings us all forward, which is great, right? So I think we should always welcome diversification, whether it's on layer 1, on layer 2, or on other fronts.
Because it's so experimental, right, at this phase, right? Because you're an academic, so you understand that more than I think most people. Like what phase we're actually in as a sector, I guess. Like
I think
technology.
the biggest challenge in if there's so many new proposals coming about is to take the time to set back and to understand and quantitatively measure what properties they achieve, right? I mean, I took like a fair chunk of my PhD to understand proof of work blockchains alone, and this only captures proof of work. So it only captures like Bitcoin, Ethereum, and reparameterization of these coins, like Dogecoin, Litecoin, and all these forks, right? That use different parameters, but it doesn't capture anything that's related to proof of stake or other types of consensus mechanism. It doesn't capture BFT protocols. So like quantifying them all together, like in an objective way, is really hard, right? And this is just conceptually really difficult. So what it mostly boils down to is that you get maybe different scaling properties in like a proof of stake blockchain, but this often comes at some kind of a drawback or compromise in terms of security.
Mm-hmm.
Now, I can't tell you precisely now what this one is, but from what I've seen, it's always like either it's less decentralized, or more centralized, or there's some kind of a way to game the system. I mean, measuring security in general really requires you to find the strongest adversary.
Mm-hmm.
So if you can't find, I mean, you first need to find what is the best attack that I know against the system, and once you have that, then you can compare similar systems. But then jumping from like a POS to a proof of work and comparing them directly objectively is really tough. I think this is still an open research question, and I don't see much research being put into that, to be honest.
Interesting.
Yeah, that makes sense because, I mean, if you look at Vitalik and now they're moving to ETH 2.0, I mean, they're pretty adamant that ETH 2.0 is going to help scale Ethereum more efficiently than proof of work. So, is there any? Have you seen any credibility behind that in terms of like, is a proof of stake something that could conceivably help with the scaling problem?
Depends on how it works. So I haven't looked into ETH 2.0 in detail, so I'm not in a position to give any qualified opinion. But I have looked a bit into some early proof of stake solutions, and they all seemed really complex and involved to me. To the extent that I get a headache when I read their papers or proposals.
Yeah.
Like the proof of stake, I mean, the lead, I think we need to decouple two things here. There's the leader election mechanism, right? If we elect a leader, and this is like we have like one particular voter that can kind of say this is the next block. This mechanism should be decoupled from what's the communication complexity on the network layer between the nodes.
Sure.
Because if proof of stake now is just electing a leader, but requires the same kind of communication as proof of work, I'm not sure how this would actually help with scaling. Right? There must be some kind of an optimization whereby we can now elect a leader in a fair and decentralized way while cutting down the communication costs, right? Because I mean, BFT protocols, for instance, they, at least the early ones from, I mean, they're newer ones now, but the early ones, like PBFT, they required quite a lot of communication among the peers, right? And this is what limits their scalability towards a bigger set of nodes to thousands or 10,000s of nodes, right? And the beauty of proof of work, right? I mean, I know it consumes too much energy and so on. I know that's not great, and but the beauty of proof of work is that you really almost only need a one-way communication, right? You have a miner, he finds something, he broadcasts, and that's it. It's done, right? There's no back and forth between these nodes. So I'm not exactly sure how the proof of stake protocols will turn out, but if they require more communication than proof of work, I don't directly see how this would help with scaling. Right? It would help with energy consumption, sure. If you use a monetary amount as a means of voting power, but not necessarily directly help with scale. So, but I'm more than curious to know. I mean, I will check out these protocols once they mature a bit more, I'm sure.
I think the proof of work argument about it's consuming too much energy, it's only because it's right now. I think if we have energy, coming from the sun, would it really matter? Like how much energy Bitcoin is consuming if the energy is being consumed, or is being provided by the sun? Like I just don't really see that as being a valid argument. Just because if you give it enough time, then we've solved the energy problem, right? So But I see your point. I think if you're right, if you have proof of stake and you have the same limitations in terms of communicating data from one node to the next, it doesn't matter how you're adding those blocks to the chain. If your choke point is the communication of data, then it's equally as not scalable as just a regular as Bitcoin, right?
Correct. Yeah.
So that makes a lot of sense. I never really thought about it that way.
It just because, yeah, I mean, I've been working a lot on the on a Bitcoin simulator, right? And in the end, you just realize it's really about network propagation. Like that's why, like Emin Gunsira, he started this BlockX route, right, which was one of the few projects trying to optimize the network layer. Matt Corallo did a lot of work on the fiber network in Bitcoin to optimize the network layer, and these are very valuable efforts because they will actually really help with scalability. And not many people worked on that, right? I mean, there are layer 2 projects. I mean, myself included, we have worked on an upper layer, which in the end also reduces network communication because you have a star topology, right? Everything goes through one hop.
Yeah.
Right? There's nothing more complicated. You don't communicate anything to the chain except checkpoints, and everything goes through one hop. So fundamentally, it's really about reducing network communication.
Yeah. So that makes sense, like, because we were doing a bunch of research at one point on EOS, and what they have is a delegated proof of stake where they delegate through some decentralized method uh, a node that's supposed to append the blocks in the chain, right? For this particular block, there's a delegated node that's supposed to append the chain. And so in this case, this method would solve the propagation of data if you know that you have to send all this information to one node to be processed, instead of propagating out to a bunch of nodes, and who knows, who's going to actually win that block, right? Who's actually going to append the chain. So it seems to add more credibility to, well, not credibility, but more understanding of a delegated proof of stake versus just a proof of stake where anybody could append the block or the chain. So this is an interesting conversation just because this will kind of lead to, dApp developers in deciding like which blockchain they're going to be, building off of. Do you think scalability has a lot of an attribute where developers really consider what blockchain they use based on scalability, or is it something that we developers expect to be solved at some point, and then they just use the chain that's most popular?
It's probably the latter, I would guess, because scalability isn't like something that most people take into account at the beginning. I guess they just want to get a quick prototype out. They want to see whether they get actually users at all. And once they grow and they see, oh yes, we get users. Oh damn, now we have to fix the scalability problem,
right.
because otherwise we can't grow. Right? Then they're gonna go into that mode. So I think it's mostly, I mean, like premature optimization is always bad, right? Like Elon Musk says, one of the worst things that engineers do is to optimize something that shouldn't exist, right? So it often doesn't make sense to jump onto layer 2 solution, which conceptually is much more complex, right, than an on-chain transaction. If you can just get your first users in an on-chain protocol.
So what's the onboarding process then for, say, like somebody like us? Are you guys getting dApps or apps, coming to you and asking you directly, like, how we want to integrate your protocol or your wallet or your service, whatever you identify it as? How would we, since we have those problems that we just kind of, we're basically those guys that ran into these problems unexpectedly, and now we're looking for a solution. So what do we do?
Exactly, right. So I mean, the easiest thing for you would be, I mean, we have a hub operator program currently that we actually had a deadline like 3 days ago for the first round, where we get application where people then want to run a hub, and they will build their own user base. They will build their own ecosystem, right, which is their own off-chain ecosystem. We just subsidize them in terms of some monetary award, like a grant, and we also do help on some of the technical, or we plan to help on some of the technical issues that they're facing. So you can literally just go to our GitHub, fork the current software. We do have also some videos that show how to run a hub. You can try this out, for example, on Robston. Will not cost you anything. And we even have the mobile apps available. If you want to use the mobile apps, or if you want to deploy a mobile app, you can fork our React Native version, put your branding on it and everything, and deploy this to the Apple App Store or the Play Store, whatever you prefer. And that's about it. The off-chain software we have does not support the execution of smart contracts. So this is a drawback that a few dApp providers kind of face, right? Because this is still very important for many dApps out there. So we're really mostly about the transfer of funds and the swap of funds. We're really optimized to this particular use case. So it depends a bit on how you if you want to, for example, create a marketplace for trading Decentraland tokens, right, or Decentraland assets, then I mean it kind of is similar to an exchange, right? Then you can perfectly run our hub, right? Because you can literally transfer and exchange those assets, ERC20 assets on this hub. But this off-chain component won't be able to how to say, what is a good use case? I don't know, maybe upgrade your land, right? If you want to upgrade your land, then probably, I'm not too sure how to integrate this into this layer 2 system. So it's more often like it's like a separate marketplace where you facilitate the trade and the transfer of assets for your users at a lower transaction cost, or like a zero transaction cost, depending on your operator setting.
Okay, so trying to understand its application from our perspective, because what we have is a user generated content, and that content ends up being an NFT, and so then we have landowners buying these NFTs and deploying on their land. So, but there's still a transfer of funds that could occur within this hub that would make more sense than using on-chain transactions for something like this. So can you explain, because from my understanding, I always thought that off-chain transactions was not transparent, right? As transparent as on-chain transactions. So can you explain a little bit how your off-chain solution is still transparent for anyone to see that a transaction took place?
That's a good question. So all the transactions that are happening in a hub, so if you operate a hub, you as an operator, you will see all the transactions, right? Because you have to approve them. You have to literally sign off on all the transactions. So this also means that you could censor some of the transactions, right? Which some people don't like. And this is one of the drawbacks, I think, of layer 2 solutions, often that you have high efficiency, but you also have this some points of failure in the sense that can censor data or transactions. Now, if you want to transmit something, what you do is you sign, like the sender signs a message. He sends this to the operator. The operator signs, okay, I approve this transfer, and then this is being the recipient is being notified about the incoming transfer. And to integrate like an NFT, I think as we discussed right at the beginning, you could potentially add an NFT token as an independent token to a hub, and then you can transfer its part or its entirety to some recipient. Then the recipient would need to, if he wants to remove it from the off-chain system to an on-chain system, he needs to withdraw the coin.
Sure.
There's some time delay. This isn't instant, right? It depends on the frequency at which the hub submits a checkpoint on chain. So this can take a day or two, depending on the parameters that you use. And then you withdraw this ERC20, and then you need to convert it probably again to an NFT at that point in time. Right?
So at that point, then you would just interact with a smart contract that says, if you have this ERC20, then you can get an NFT out of it. That makes sense. So, so there isn't a ledger for this particular hub that people can go view transactions, right? So it's
there is. So I mean, we have on Explorer.liquidity, the network, we have kind of, it's similar like a block explorer, but for layer 2, right? Okay. We also open source this. It's a UI that interfaces with the API of the hub. So a hub always has an API with which the clients communicate. And in addition to this, we made a prettier UI for users if they like for hub operators, if they want to provide a user interface towards their users. Now, It depends a bit. So because you're asking about transparency. So the hub operator can choose to make public everything, right? I mean, for our hubs, we have chosen to make everything public. So you can always query the API of the hub, get the latest transactions, get the sender receiver amount. Everything is public. Even for swaps, that's also possible to just visualize everything. But it's true, you have to trust the operator to give you that data, right? Because he doesn't have to. So there's nothing that can kind of force the operator to give the data. Well, you could choose to push this data to IPFS or to some other decentralized medium, but then again, we're running into scalability bottlenecks, right? Which in the first place we're trying to avoid. And so what we have seen also, some hub operators will probably choose to not make public the transactions because it's in the interest of privacy of their users, right? So if you have an exchange, or if you have if you can just like send coins and you don't make everything public, then who knows who deposited it in this address or withdraw from that address? You don't know, right? So it can actually function as a mixer if you do trust the operator. So the operator can see everything. The cool part is that that the no-cost operator is not required to keep logs for more than 2 checkpoint intervals for operation. So in a sense, the operator can really purge the past logs if he wants to. It's not required for safe operation.
So explain the checkpoint. At what point would signify something that needs to be checked into, a first layer, blockchain?
Yep. So we have like in the current mainnet hub that we have a 36-hour checkpoint interval. So this means every 36 hours we commit a root hash of the Merkle tree to the smart contract. The cool thing about this is that the operational costs of such a hub are really low. Like deployment costs like roughly $100, right? And one checkpoint is like between $2 and $3 at the current gas prices. So it's really cheap.
Oh, wow. Okay.
So the operational costs for the operator, at least for from that point, is really cheap, which is nice. Then so if you deposit coins, they're almost immediately available. I think we have a 60 block security period where we only allow them to be traded, to be transferred in the hub after 60 blocks. If you want to withdraw, it's going into two phases. You have to initiate a withdrawal. So you have to say, I want to withdraw. And if the operator doesn't complain, so he says, if he doesn't say anything, then you can later confirm your withdrawal. So this period can take up to 2 checkpoint intervals, which is 72 hours. So it's quite a while, right? So it's not always ideal for some traders that maybe want to take out money quickly. So that's certainly a bottleneck. Now, what you can do to alleviate this issue, you can either shrinken the time interval for the checkpoint. You can make it smaller. Making the checkpoint smaller is kind of similar to making a smaller block time interval, right? The issue with smaller intervals is that your users, they have to come online once every checkpoint to verify that their balance in the checkpoint is correct. It's something we haven't discussed yet. It's the online availability or the online or the online requirement of most layer 2 solutions. So a user must come online once every checkpoint interval in order to verify that their balance is correctly allocated in the Merkle tree. If it's not correctly allocated, they would need to issue a challenge to challenge the hub, basically the smart contract. So you can play around with the period. We recommend longer periods, because then you also have a leeway to debug the operator in case it misses submitting a checkpoint or it crashed or something, right? You have a bit more leeway kind of to rescue, in a sense, the hub.
So the challenge is really there as a safety measure for the users of the hub.
It's very important.
So that means, like, if I run a hub and I do something malicious, I guess anyone using that hub can issue a challenge, and therefore I can't do anything. I can't submit that signature onto the chain because there's a challenge on the hub.
Yes.
Interesting.
So if you get challenged as a hub operator, At least our smart contract, right? You can change your smart contract, but our smart contract at the moment, it freezes the hub operation. This means no more checkpoints allowed. Nothing will be, basically it's a rollback to the last checkpoint.
Interesting. Okay.
Um, we do that because I mean this is a significant event, right? So all the users of this hub, they will be aware that something went off because their coins either have to move or so. And it's I think we find it's important that that the hub stops if the hub tries to defraud to only one user, right? Like if there's already one user that's kind of a victim, and then it can be any user, right?
Yeah,
So there's
correct.
at least it's our policy so far. So what you could also do in addition to this, you could set up like a security collateral, right? You could say, if I die, if the hub stops operating, or if I get successfully challenged by someone, then I don't know, there will be these 10,000 bucks that get burnt, right? You could come up with such incentive schemes to deteriorate misbehavior of the hub operator.
Mm-hmm. So let's walk through a scenario. So the three of us, we're on a hub, and let's say in this hub you've amassed, hundreds of thousands of dollars, and Iman sees his balance as not correct, so then he issues a challenge. So you're saying without that checkpoint being submitted onto the blockchain, then your balance within the hub isn't yours until that checkpoint is in.
So your off-chain balance that you see is not your balance unless it's confirmed in a checkpoint. Yes.
Okay, makes sense.
So there's a delayed finality.
Yeah. So what this provides is, to put it in simple words, is that you could do thousands of transactions within the hub for a single gas fee.
Yeah, I mean for no gas fee. Right?
Well, no. Well, so yeah, it's no gas fee during those thousands of transactions. But as soon as you submit it into the block, into the main chain, then you do have to pay for that gas, right? That one transaction.
But that's the operator, so there's no user paying for this.
Okay.
This is always at least in our model. Yeah.
That makes sense, because if you run a business based on this hub, and your business makes money, then you just pay the one gas fee as a business to submit everything.
Correct. Yes.
That makes sense.
So you kind of subsidize the cost of this. I mean, because they're not very high, right? I think it's reasonable. If you want to have instant finality, you can also achieve that. We specified this in our paper. It's a bit more complicated, but what you can effectively do, you can say every checkpoint interval, Iman can receive 10 ether, right? So if he gets sent 5 ether, then these 5 ethers, they're insured by this collateral that was put up like exclusively for him, for his account, right? And if he receives 10 ether, then the hub goes down, he still received those 10 ether because he can claim them from the smart contract. If he now receives 15 ether, then he won't be able to claim that these 5 ether that are overlapping, right? He can only claim the 10. So if you need instant finality, like a payment channel offers, right? Like a payment channel has collateral and you have instant finality. Therefore, like I have to be a bit careful, because some folks that are listening will probably say, "Oh, this is still not finality." We call it economic finality, right? Because in the end, you get the money. So
right.
Yeah. So you can get economic finality if you put up collateral. That's possible. Yeah. But it requires a bit more. I mean, it would require more engineering on the back end to make sure that this is properly allocated. And
Okay, so if you watch us long enough in our podcast and our YouTube, we do talk about Decentraland a lot, but there is a lot of trust within our community on what we're doing, because our project is not funded, and so we built our DApp based on the ideologies of lean startups, and so we built the most minimum viable product that we possibly could, just to test out our assumptions on this application, right? This DApp, right? Yeah, and so a lot of the stuff that we built was completely centralized. Everything, all the transactions, obviously the transactions are on chain, just like you would expect. However, the interactions within the community, within our DApp, they're all essentially centralized, and we're working towards decentralizing everything with smart contracts, and then issuing NFTs based on these purchases. Because right now people are trusting us that the creations that our community makes and submits into our DApp eventually will turn into NFTs that they can deploy. So for now, our users are depending on us to handle all that minting process without them actually being NFTs, because when we were building this DApp, we didn't really know it was going to work until it was actually tested. And so now that we know that it works, we're working towards decentralization. So all this is to say, my question is, when you built this hub mechanism, there's still inherent trust in the hub operator. Do you see any pushback from your community on having to trust a hub operator in a space where no one is really supposed to trust each other, and that's why we're decentralizing everything?
It's a very good question. So unfortunately, from our community at least, we don't hear anything, to be honest.
Oh, really? Okay.
Which is kind of alarming. I think I'm the one who's like,
Yeah.
we have to decentralize. Other people have to run hubs. We like. I don't think like. I mean, it's maybe because my background is more in academia, and I've been working like most of my blockchain time on the academic side of things, right? But yeah, I'm really pushing very hard now that other people run hubs. It's not like anyone from the core team that's running hubs necessarily, because it's the only way that this is really getting traction in a broader sense, and not controlled by any single entity or person. So yeah, you could, for example, run several no-cast hubs, right, for Decentraland if you wanted to.
Sure.
Right? This is certainly something I would recommend you to do, because then you have less risks, right? Because if one hub goes down, well, so what? It's just one hub. It's not all of them. You have less centralization, because in the end you will have somebody with a key to sign these transactions for the hub. Alternatively, what you could do is to come up with some kind of a permissioned blockchain that operates the hub server, right? That represents the server, but then you run also in some scalability issues. I think it's just it's a good like one app or one use case or one, I don't know, one continent in Decentraland, one hub is a good model, right?
Sure.
Because you could, I mean, this is kind of what we had envisioned too. You have like one hub per country or one hub per major city or something.
Sure.
This makes sense, right? Yeah.
So I would say, yeah, because like from our perspective, we would run our own hub for our own DApp, and then anybody in Decentraland can run their own hub for whatever they're doing. I wonder. So your users right now, you're saying that you're encouraging others to run their own hub. Are you onboarding users to an existing hub? Like, are you able to run a multiple set of different types of transactions? Say, for example, a hub is running multiple dApps within the same hub. Is that possible?
I mean, again, we only support the transfer and the swap of assets, right?
Okay.
But you can support multiple tokens. So there's no limit in the sense to how many tokens you support.
Okay.
Well, there is a limit technically, because you need the checkpoint probably is going to be a bit more expensive if you have like millions of tokens. So
Sure.
I would need to look into that. But but technically you can have multiple dApps using kind of this transfer or swap functionality from a single hub. That should be possible, I guess.
Yeah. Because in this case, you would only need to trust the operator of that hub, and it doesn't really matter what transactions are happening within the hub. You just have to essentially trust that the operator is going to not do anything malicious with those transactions.
Yeah, I mean, trust is a difficult word, right? I mean, if and this is a big if, right? If users follow the protocol specifications, that means they come online, they use the client, they do verification that everything is right? If they do come online every 36 hours, for example, if you have this kind of interval, then technically you don't have to trust the operator, because this is non-custodial, right? The operator has not access to the user's funds. But it's true, if the users don't come online, then the operator can be malicious and can change their balances without them, basically steal their balances. That's possible. So it's kind of the same thing in Bitcoin, right? If you don't follow the protocol of verifying whether your transaction is actually included in a blockchain, you just accept a transaction that is like a zero confirmation transaction. You accept a zero confirmation transaction, and it's your loss, right?
Yeah.
You didn't follow the protocol. So, but you're right. If the hub does something malicious against one user, and at the end of the day he gets challenged, then you have more work, because like the other the other users have more work because they need to basically clean up the mess, right,
Sure.
with the hub operator.
Yeah, because the one challenger is really holding up everybody else's balances.
Yeah.
Yeah, that makes sense. Um, no, I like where this is going because it has a lot of applications within Decentraland, at least. And I know we talk about Decentraland a lot, and we're trying to not talk about it as often, just because there's a whole lot of innovations happening within the space that we want to like explore as well. Just because it's one of those. I don't know if you remember, like in 2011. We all probably heard about Bitcoin early on, but most people tend to blow off anything that they don't really understand. And we're trying to avoid that by exploring everything that's out there and seeing what everybody is working on, just so that we don't miss an opportunity for being early on a project that you believe in, and like, for example, in Tesla's case, or obviously in Bitcoin. So I like seeing all these innovations, like from a technical standpoint, because I like to understand like how it's being applied. So could you like tell us like what are some of the projects that are using the Liquidity network that you might want to like showcase or explain what they're doing?
So we have, for example, we have one MicroMe service. This is like a micro tipping service for social networks. I think it's micro with a Q.
Micro with a Q. Okay.
Yeah. This was one basically a service from a third party developer that developed like micro link, so you can tip people in social network. It's very similar to the have you heard about the tip in me
Yes.
for the
Tipping me.
Bitcoin?
Yep.
Yeah, it's something similar, right? And it goes in the same direction. So I think the architecture we have is really destined to high frequency microtransactions, right? It works best if you have like a lot of small transactions. Because it is relatively cheap. It's very cheap actually to do single transactions, so you can do many small value transactions very
Mm.
well. So this is, I think, one example use case. We have built actually an exchange that you can find on text.liquidity network. Let's share the link. This one here. It's a full blown exchange, like with an order book and so on, that works off chain on top of this on top of the Nocust hub. You can actually use the software. So we have open sourced this part as well. So the UI of the exchange is open source, and the hub software we have already has all the logic of the exchange included. So as well as the order book logic and everything. So you can really deploy your own text, if you will, today with this software package to try it out.
Oh yeah, no, absolutely. We'll definitely check it out. I wonder what was your like outlook and perspective on the differences between a bear market and a bull market in terms of like your business. Do you see less traffic, less activity during a bear market, or is there no difference? Because the way that we see it is there's sort of like an 80-20 rule when it comes to crypto projects, is that 20% of the audience is really interested in the technology and the innovation and the development, and the 80% is just there for the speculative projects, like trying to make money, right? So what have you seen like in terms of activity between the two different like bear and bull markets?
Yeah, I have the feeling, but maybe I'm wrong. I have the feeling there's more building activities if prices are rising.
Oh, more
Like
building.
I've
Okay.
Yeah, maybe not, no, not more building, but more marketing activities that claim building. Yeah.
Yeah,
So
that's a distinction.
yeah. So I have the feeling that if there's like a positive upward trend, that a lot of people are suddenly claiming they have the best solution to everything, and
Yeah. Yeah.
while the builders, they just keep on building,
Yeah.
like irrespectively of what the prices look like, right? Because it's a cycle after all.
So basically, when there's a bull market, there's a lot more talking and a lot less doing.
Yeah, yeah.
Yeah.
There's a lot of talking. Yeah. I think I mean, there were some people. I mean, okay, Twitter is maybe not the best example, but some people claim that layer two solutions, they spend more time on comparing themselves to other layer two
Yeah.
solutions than on attracting users, right?
That's right.
And that's probably true to some degree sometimes, right? Which is not necessarily healthy, right? I mean, but I certainly recommend you to check out all layer two solutions on Ethereum. There are excellent ones out there.
Yeah.
With and everything has drawbacks and benefits, right? That's just how it is. Yeah, we wrote an SOK that kind of like academically compares the different layer two solutions. It doesn't contain rollup though, so because rollup wasn't or isn't yet fully specified in any paper, and I think rollup is quite an interesting technology that you should also have a look at if you haven't yet. I guess you have already.
Mm-hmm.
So let me share this with you. So this is SOK in the academic world is an acronym for systemization of knowledge. So we try to kind of like, yeah, how to say, compress all the existing academic related works on layer two, right? And this means it's handling over channels, commit chains, and also other constructions. It's fairly technical, right?
Mm-hmm.
But I mean, it gives you a good high level overview. This was published at the beginning of the year in February at the conference. So it was, I mean, we wrote it last year, right? In the beginning of last year, and then it takes like almost a year to go through the review process and so on.
Sure.
It was published at Financial Crypto, which is a fairly good conference in the space. But it's missing, I mean, if I look at it now, it's missing, for example, all the things roll up that are really interesting. Could be that there's some more detail, like Starkware has an interesting DEX that I'm not sure if it's probably roll up related. But it might give you an overview, but yeah, it's obviously not complete.
Sure. I'm curious, what's the business model for Liquidity Network? Like, if I take out a hub, how do you guys make money?
So yeah, we actually don't directly make any money if you run a hub. So I mean, we believe in decentralization, right? So this is kind of your business and your user base in a sense, if you want. I don't like the term of your user base because it's a centralized connotation. But yeah.
Sure.
So for the hubs that we support, we have as a requirement that they accept our token LQD as a means of payments for additional rewards. For example, on our hub at the moment, you can do 100 transactions per day if you're a normal user. If you want to go beyond that, for example, if you're a business or something, then you need to pay one LQD token to get more transactions per day. Obviously, this is not a substantial amount, right? But this is kind of the way that hub operators can monetize, for example, their transactions, right? So it's good because there's like an upper limit on the spam that the hub server needs to process also, right? You want to have some kind of an upper limit there. But if you, for example, don't want to participate in our grant program for hub operators, you don't have to take our token, right? You can use your token or any other token. That's not a requirement. It's like really, it's a free software for everyone to use in whatever ways they think it's beneficial.
That's interesting. So by using your token, then you're adding utility to your token and therefore increasing the value. And okay, that makes sense. Yeah. Well, on that note, I think we've spent an hour. I don't want to take any more of your time, Arthur. I want to thank you for joining us. I think this has been very helpful for us to understanding like the technology. This is very valuable for us and to many in the audience, just because reading PDFs and reading websites, and it's just not good enough, right? It's
no,
you gotta,
the human factor is missing.
yeah, it's definitely missing. And this is, and I know this takes a lot of your time doing these interviews, but it's very helpful from our standpoint in terms of like trying to figure out, what is the best way to do a business using, cryptocurrencies and dealing with all the difficulties, that come along with using cryptocurrencies as a payment mechanism. And then on top of that, trying to be as transparent and decentralized as you can, which is, something that people are not used to, waiting for, 20, 50 confirmations, right? It's not a thing that we've grown up, doing. So having, the opportunity to talk to you and have you explain this technology really helps us in like trying to figure out like what we should do in terms of, getting this right. Because, in business, you only really have one shot. And if you have more shots, you're just lucky, right?
Yeah.
So thank you for being here, Arthur. I really appreciate it.
No, it was a very pleasant talk. Thanks a lot for your time, too.
Yes. Hopefully we can do it again. And thank you guys for watching. And make sure you go to liquidity.network and check them out. I know we will, simply because we sort of need a solution to all these like gas fees. So thank you,
Awesome.
and we will see you next week.
Thank you. Have a nice day. Bye.
Bye-bye.
All right, bye-bye.